select your courses. Has anybody selected their courses already? Okay. Now I don't know if you can like redo that, so make sure you get it right the first time if you can. Let's see here. So your warm up for today is just to put what class you're going to take next year. Okay. So here's your options. And by the way, this is important. The counselor said, look up here, everybody, look. Do not pick a lunch, okay? It's not going to help you get that lunch. If anything, it's going to frustrate them. Maybe they won't give you that lunch, okay? Again, you don't pick your lunch. It's just going to make more work for people that you want to not be on their bad side, right? Okay, so again, don't mess with lunches. Now, here are the courses you can take next year. Geometry students. Normally, after geometry, algebra 2. Normal, okay? Or typically. And this is required for graduation with an endorsement, okay? Regular, that's next, okay? Now, if this class is so easy that it bores you to death and you want to cry every day, then Algebra 2 Honors might be better for you, okay? Because you're looking for an additional challenge, and maybe you want to take an AP Math course. That's possible, okay? Another thing that's a little bit challenging is statistics, okay? If you're planning on majoring in a field that will need statistics, such as nursing, business, or psychology, and if you want to see a different kind of rigorous math course. Rigor is a fancy way of saying difficult. I mean, not just difficult, but challenging. Challenging is good, okay? So rigorous, okay, is challenging math, okay? Now, right here, look at this. This is algebraic reasoning. So if you want to probably be stuck with me again next year, algebraic reasoning, right? So you choose this option. It says if, oh, it doesn't actually make sense. This course supports and extends Algebra 1 concepts, okay? So let me tell you what this class really is. This class is really Algebra 1.5, okay? We do a little bit of Algebra 1, and we kind of do a little bit of Algebra 2 before you get there, okay? So again, if Algebra is kind of tough for you, Algebra 2 might be tough for you, so algebraic reasoning might be a good stepping stone before you get there, okay? So most people will either take Algebra 2 or algebraic reasoning. So make sure you write one of those down on your warm-up so you get credit for it today, not folded or crumpled. Okay, so make sure you have that written down, easy warm-up. Now, we're going to do some brief notes because we're getting into right triangles. I did post in the Google Classroom that the counselors are going to be available for questions at a certain time. You want to look at that flyer. Okay, here we go. Pythagorean theorem. Okay, let me pull this up. All right, so while we do this, everyone's looking at the front without headphones in our ears. Okay, and not on our phones or taking a nap or anything like that. Okay, so everyone's looking up here. So, Pythagorean theorem, okay, is a theorem that was developed by Pythagoras, okay, this math dude. Okay. He knew a lot about math, but he also had he knew a lot of stuff. People followed him around. He's kind of a cool guy, I guess, back in the day. And we still use his theorem to this day. So let's go ahead and start filling in these blanks. The blank, the Pythagorean theorem, okay? Okay. The Pythagorean theorem is a rule that describes the relationship between three side lengths of a right triangle. It only works for right triangles. Okay, a right triangle is a triangle with one right angle, which we already knew. We should have already known that. Now, this is important. The longest side opposite of the right angle is called the hypotenuse. Y'all heard that before? Heard a joke about it before, maybe? Hypotenuse. Okay. Now, it says it's the longest side, and it's opposite the right angle. So look on this picture. Here's a right angle. Across is my hypotenuse. Label that too. Hypotenuse. Always across from the right angle. Okay. Now the two shorter sides are called the legs. Two short legs. Now, maybe this can help you remember, okay, when we talk about right triangles, two legs, like everyone in this room has, two legs, okay? Now, the two legs make a right angle, so I'll do this once as a visual. Ready? A right angle and your two legs, okay? So imagine doing that, and not falling over, okay? So you got your right angle with two legs, and across is the hypotenuse. That's how it works, okay? Now, there's the theorem. A squared plus B squared equals C squared. You all seen that before? Okay, hopefully, presumably. But what's A, B, and C? So it goes on to tell us what? Okay, Pythagorean theorem says A squared plus B squared equals C squared, where A and B are the legs. Let's label that on the picture. Leg A, leg B. It doesn't matter which one's which. You can switch them around. It is what it is. Okay. C is the hypotenuse, the longest side. So can't you see that the longest side is the hypotenuse? So A, B, and C. We use this theorem to find the length of one missing side of a right triangle when you know the other two sides. All right? So, you finished? Okay, take your turn. 1 second. All right. So, it's important that you know where A, B, and C are. Now, there's two examples we're going to do today, and then we'll be done. So we either know the two legs, or we know one leg and the hypotenuse, okay? So, let's look at example 1. I want you to label A, B, and C every time, unless you get really good at this and you just mentally know it. But this can be confusing. So, y'all tell me, which one's A? 6? Sure. What's B? 10. Everybody, A and B are next to 90. 90 is A and B next to it, right? Okay, and then across is what? C. Now, there's nothing there, so I'm going to put X, okay? Usually when I have a missing value, it's a variable, X. Now, A, B, C. Now, A and B could be swapped. A could be 10, B could be 6. Doesn't matter, but C matters. Okay? Across from 90, the longest side, the hypotenuse. Okay, what is the Pythagorean theorem? What am I going to write down? What is it? A squared plus B squared equals C squared. Yeah? You need this? All right. Now, we already know what A, B, and C are, so let's label it. So instead of A, I'll write 6. Instead of B, I'm going to write 10. Don't forget the squared. And then C will be X and then squared. So I just substituted A, B, and C. No big deal. Now, I'm going to use my calculator. You don't have to if you're a pro and you know this stuff, but some of us need to check ourselves. 6 squared. What's 6 squared? Okay, 36. Okay, now second period said 6 squared was 12. What did they do wrong? Or they did 6 times 2. They see the little 2. Oh, 6 times 2. 6 squared means 6 times 6. And if you don't know, please, calculator is your friend. 6 squared is 36, right? What about 10 squared? Is it 20? Is it 1,000? Okay, it's 100. Again, 10 squared. Now, once you square the numbers, you can combine like terms. 36 and 100 are on the same side. What's 36 plus 100? 136. Now, our goal was to get x by itself. Is x by itself? Why not? The little 2, the squared. Okay? Squared needs to go away. So what's the opposite of a square? Don't say a circle. What's the opposite of squaring something? It has the word square in it. Square root. This is my square root symbol with my hand. All right, so to get rid of the square root, both sides. Okay? You got a square root. So square root of the left side. Let's try that again. Square root, square root. Now, when you square root x squared, the square root and the squared cancel out. So I like to scratch them out. So square root goes away, squared goes away. Now I just have x. Cool. But now I need to know the square root of 136. So I just type it in my calculator, right? No! Okay, what have we been doing for the last week? Factor tree. Okay, so it's going to ask you to give it in simplified radical form or reduced radical form. Or you have a headphone in your ear and that's kind of, you know, clogging up the ear canal. Yes? It would give you the answer to a different question. Like if I said, give me the approximate or the decimal answer, then you could do that. But if I say, like right here, simple radical form, do you see? Okay, then we want to do the factor tree. Let's do that. Square root of 136, I'm going to do it off to the side here where I got some more room. Square root of 136. What do I do first, everybody? Okay, factor tree, and let's try 2. 2 times what? If you didn't know, divide it by 2 in your calculator, and you do get 68. Cross out 136. Now, 68 is also even, so 2 times 34. Cross out 68. 34 is also even. 2 times, and it's 17. 17 does not have any factors besides 17 in itself, right? So 17 is prime. Cool. Now, do I have any pairs? Yes. Pair of 2, cross one out. And then 2 loners. So what do I write for my answer? What goes out? And what goes in? 2 and 17 are going to multiply. 2 times 17 is 34. Okay. Now, let's recap. What did we do? We labeled A, B, and C. We figured out what are our legs and our hypotenuse. Goodness gracious, go away. No. Go away. Thank you. Okay. Again, what did we do? We labeled A, B, C. We plugged it into the Pythagorean theorem. We squared our numbers. We combined like terms. We square root. and then we factor tree. That's how you do simplified radical form Pythagorean theorem. If you're missing the hypotenuse, okay? Now, look at example 2. Let's label it. What's A? 5. What's B? Who said 13? Everybody. A and B are next to 90. A and B are next to 9B. So what's B? B is down here. Y'all see that? It's missing. I'll put an X there. Okay, so B is the missing side. We'll label X. Thank you very much. And then what's C? How do I know C is 13? Across from the 90, the longest side. Hypotenuse is C. Okay, now, once you labeled it, let's write down the Pythagorean theorem. What's the Pythagorean theorem again? A squared plus B squared equals C squared. Now, let's plug in A, B, and C. What's A? What do we put in? 5 squared plus X squared equals 13. All right. Now, everybody, I'm going to make a big deal about this. Look right here. Oh, fumble. When I was missing the hypotenuse, X was on the right by itself. When I was missing a leg, X was on the left. Thank you. I'm missing a leg. That was a joke. All right. No offense. Hey, be nice. Be nice. All right, so real quick. X was on the right. X is on the left. There's a difference. Let me tell you, some people are just going to always, this is wrong. They're always going to put the two numbers here. But it doesn't work if you're missing a leg. Okay, so let's do the math here. Let's square these numbers. What's 5 squared? 25. X squared stays the same. What's 13 squared? Is it 26? Could it be? 13 squared is what? 169. Because we know squared does not mean times 2. It means times the same number, right? Okay. Now, here's where this is a little bit different. Gustavo, X is here. I need to get X by itself. So this loner, 25, has to go. It's positive. So what do? No. How do I get rid of a 25? Subtraction. Minus 25. Minus 25. And then what's 169 minus 25? 144. And that's my answer, right? Why not? Oh, the square has to go away, so I'm going to square root both sides. Okay, so square root of 144. Now, I already heard the answer here, but this is a square number. We hopefully know what the square root of 144 is. What is it? 12. Now, if you don't have that memorized, no big deal. But here's the thing. You're going to make a long factor tree. And then you're going to find 3 pairs. And some people get stuck here and we're like, what do I do? Because there's no loner. There's no leftovers. Well, check it out. If you have 3 pairs and no loners, then all you do is multiply the 3 pairs. What's 2 times 2 times 3? 12. 2 times 2 is 4. 4 times 3 is 12. That's what you get. So whether you do the factor tree or whether you already know 144 is a square, square root of that is the whole number. Okay. But it's very important that you know how to do this when you're missing a hypotenuse and when you're missing a leg. Okay? Now, we're not doing practice on this because I want to give you a little bit of time left over in this class because this assignment on simplifying radicals needs to be done, or missing work, or if you have a quiz to correct, okay, I will come give it to you. So is everyone good on this? I'm going to close it up.